The 360 on Energy and Carbon, hosted by 360 Energy. On today's episode, we are joined by John Norman, president at HydroStor. John is a professional engineer with over 20 years' experience in the power industry, management consulting, and government. John currently oversees HydroStor's strategic growth as president and was previously chief operating officer. Prior to HydroStor, he held senior roles at Brookfield Asset Management, including leading commercial development, regulatory policy and government relations across North America and Europe for the power and utilities business. Now let's get into the episode with John. Welcome back, Dave, John, and John Norman, president at HydroStor.
Hi, Lysandra.
Great to have you back, John, and good to see you, Lysandra and Mr. Pooley.
It's really nice to be together again. Okay, I'm going to start us off. Just a bit of placement. In our podcast series, we've been talking about net zero, but we've been talking much more about energy transition, partly because we think people will engage with that better, and also it is a definite that we've got to do. So my question for you, it really is, what's the role of compressed air energy storage in the energy transition?
Yeah, I mean, we talked a little bit in the last episode about just what's driving the need for long duration storage generally. And the big part of that is the fact that a lot of fossil plants are retiring. No one's building new ones, as they should not. Clearly, climate change is accelerating. I think we're all seeing the impacts of that. And as a result, the push for decarbonization is even greater, and the renewable penetration is increasing. So how does compressed air help out with that? Well, first of all, I think long duration storage itself is becoming more and more critical for that. I think the signals have even increased over the last 2 years since we last spoke. And a lot of grids that are facing reliability challenges have put mandates in place and are really actively pursuing that long duration storage. I think what's neat about compressed air in that context, particularly advanced compressed air, which is our fuel-free process that can be flexibly located, it sort of does form a backbone of the system going forward. I think there's a lot of talk about, a shift to decentralized generation. We can debate the merits of that versus not, but I don't think you're going to have a completely stranded trillion-dollar, multi-trillion-dollar grid infrastructure. So you still need centralized generation points that largely need to replace fossil fuel or maybe nuclear that's been doing that over just decades and decades. We're perfectly suited for that. We can flexibly locate there. We provide the same type of inertia on the system, which grid planners really like because you have a lot of this asynchronous generation coming onto the grid. It's tough to maintain reliability and all the standards that are required without that spinning, rotating mass. It's exactly what we do. What's also sort of neat about us is that even within the long duration energy storage space, we're very well positioned. So, we're providing really unique services there. We're not sort of putting a bank of batteries together and trying to make that into long duration storage as an asynchronous resource. We really are sort of replicating what these fossil assets have been doing, but doing it in a way that's not using any fossil fuel. So that is, makes it really perfectly suited for the energy transition. And like I said, we are very much, looking forward to other solutions being out there too, because they all provide different types of benefits, particularly on a decentralized level and perhaps behind the meter type applications. Whereas we're really good at replacing these assets that provide reliability services. Is really a core business case for us.
Thank you. Yeah, that makes sense.
John, let me set this up. We work with end users and in the marketplace, large end users, and typically, they use a lot of air compressors and our knowledge and experience with air compressors, it's a requirement, but it's one of the most inefficient pieces of a kit in an end use facility. So I'm setting this up because I'd like for you that we have you'll want to know, we have engineers that listen to this. We have students that might listen to this, but what is the efficiency of a compressed air storage system? Can you share again how that fits into this whole equation?
Yeah, I mean, I think that To start, I think the distinction that we're advanced compressed air is really important to begin with as well. So if you're looking at with traditional case, and there's proponents out there doing that, and they can certainly provide benefits to the grid, but they're not really emission free. And what's sort of interesting about that is, like, sometimes I've seen compressed air energy storage traditional providers say they're 100% efficient because they're sort of taking all the stored energy and putting it all back onto the grid. But they're doing that by burning natural gas. So like if you look at the full energy life cycle, they're typically 35 to 40% efficient.
Right.
And it's, it only makes sense for very specific use cases that have a specific purpose. And then they have the siting limitation. But in our case, we are a true storage asset. And so our efficiency is actually between 60 to 65%. So in other words, everything going in, including all the the losses on electrical and everything else coming out, high voltage AC to the system, is 60 to 65%. So a good way of kind of conceptualizing that is we're kind of like pumped hydro. Now, what pumped hydro is doing is they're taking that same water head as us, and they're running it through a turbine directly, and then that's more efficient. So they're typically 75, 80, maybe low 80% efficient for really good ones. The challenge with that is they require 20 times the volume of water to serve that purpose. So that's where you hear the challenges of pumped hydro plants with, can they be built? Can they be permitted? How much are they going to cost at the end of the day? A lot of the low-hanging fruit for pumped hydro has already been taken in the world. So we're sort of like pumped hydro, but another way of describing us is like pneumatic pumped hydro. That's actually, we didn't even really invent this concept of the water compensation on the gas. It's been used for certain types of applications. But if you think about how that factors in on efficiency, so now we're using that same water head, we're transferring that energy to compressed air, which is obviously a lot more space efficient. And then we're running that air through a turbine. So that's obviously less efficient. What we find for the applications, though, is that ability to flexibly site where these fossil assets require it, or where there's retiring or there's a reliability need on the grid, is way more important than that efficiency difference. Now, I think what is also important to note, though, is that only goes so far. Like, once you're getting below 50% efficiency, I think that's a bit of a challenge unless it's very niche applications and has other very specific benefits. So we've really been trying to maintain that sweet spot. What's also sort of interesting about us is we see ourselves really more as a systems integrator and an innovative systems integrator, as opposed to like a new technology provider. And that's why we've been very successful at bringing this on the grid and being really third immediately available pathway for long duration storage. And that's partly because we're just literally integrating off the shelf components that are very well proven how they operate around the world in similar applications. Now, if we were to re-engineer compressors to target a higher efficiency for our system, we could do that. But then our compressors would become lab experiments. We could target probably 70% plus, but that is not actually a good use case right now. And that slight benefit in efficiency is actually not as important as the immediate reliability benefit on the grid. So that's how I would sort of characterize our round trip efficiency. But the short answer to your question is it's 60 to 65%.
Thank you for that.
That's good. Okay, so if we want compressed air, hydro, pumped storage, long-term facility, whatever we're going to call it, if we want a HydroStor project to go ahead, who are the key stakeholders? What makes it happen?
Yeah, I think, building on the response to Dave's question, it's important to realize that the technology in our case is already here. So who our influencers aren't necessarily aspects of our supply chain, or we have things that we need to prove or pilot or demonstrate. That's all been done in our case. We're really trying to build out that long duration storage market, and we know we can compete in that market, and we want to have technology neutral competitions really around these things. But making that happen in our case, because we're a pretty large scale asset, means we're dealing with a lot of regulators that manage like how money is spent on the electricity system, manage how the transmission system is used, and grid planners who are managing the generation and storage choices in the future. And really, those are two key audiences for us. We have a pretty sophisticated government and regulatory affairs team in order to work with them to get the right solution for their needs and then be able to provide them solutions where appropriate. But the regulators are important for several reasons. They often control the pocketbook. And even in cases where there's more an ISO doing grid planning or something similar, or the load serving entities are doing it, the regulator's almost always regulating the transmission and distribution system. And, regulators are slowly waking up to, the need for, to Sandra's point in the earlier episode about the need for adaptability on, you can't just strictly have a transmission asset or a distribution asset and then there's no cross subsidization. I mean, the whole point of storage is to provide services along all of these value chains. And so there are regulatory barriers to that now. They're trying to charge demand charges to the load side, despite the fact it's providing benefits to the grid. I'm not saying that's every jurisdiction. A lot of them have addressed it. Not all of them have, and some are struggling. And then most jurisdictions are struggling with how you use storage as a non-wires alternative. And as instead of building up billions and millions of dollars of transmission, you can have an asset that's providing grid services while offsetting that transmission need. But they always want the asset to be one or the other. Well, that's not a good outcome for the ratepayers. So they have to buy two solutions then, right? So regulators, I don't want to, get all over regulators, but they need to wake up. It's not, and they're not doing it fast enough. And even in jurisdictions where they're leading the way, and I won't name any names on it, we're working in some of them, they are struggling and they need to move faster, to be totally honest, to catch up to what the need is. So I didn't necessarily mean for that to be kind of an advocacy push, but those are two really important stakeholders for us. I think the other one that's actually really important underlying that is the general public. I mean, that's the value partly of these types of podcasts and for well-informed listeners. And then even the mainstream media in all its forms needs to be spending even more attention on it. I think they're starting to do that and the public's starting to engage on it. But the reason that's important is that public interest does need to drive policy. And it's not just as simple as setting climate targets, although that's critical. It also means, there's decisions to get made on how we're going to adapt our grid for the future to a decarbonized system. Is it just a cost basis? Are you looking at other benefits that systems can provide? How is the public engaged in that? And we're really trying to build out even our external communications capability around this stuff to really help facilitate that. So those are, for us, the really critical stakeholders. We tend to be a larger scale asset. The only other one I would maybe mention is commercial and institutional users, because they often are filling leadership roles where at least there's delayed action by this group of either grid planners or regulators. And if they have a significant amount of load, they'll try to use that to make decisions on how they want to be decarbonizing their usage. Now, we tend to be more on the front of virtual power purchase agreements or those sorts of things because we tend to be larger scale. So we want to work with lots of different users. But we do see that model becoming more and more important, and certainly not counterthetical anyways to the broader grid regulatory model. It's just that model is not going away. I think the commercial and institutional world can show even more leadership and can become an important part of driving this as well. But I would really highlight, even in that case, that the public engagement is really important to drive corporate decision making as well as government decision making.
Yeah.
John, I'm going to slightly adjust the question because it's been stated a couple times that effectively, the solution that HydroStor has is really for grid scale. This is not for like a site scale solution, right? It's not for any particular type of customer. I don't care if it's if they're a 100 megawatt organization, you were saying like 500 megawatts, 200 megawatts type. Is that correct? Yeah. Did I capture that correctly?
Mm-hmm. Yeah.
So, but here's my question, because certainly Lysandra and I have been involved in a situation where an industry in particular has significant growth. And I understand you work with the grid, but has there ever been an industry sector as an aggregate approached your company as a potential solution to help them out in their growth going forward, or has it always just been grid people, regulators? Has that ever been brought to your attention, or has anyone spoke to you about that?
Yeah, I mean, first of all, the answer is yes. I mean, there's definitely corporate leadership out there. I mean, the important thing to realize is corporations are sort of all over the map. They're doing different things. Some of them have high electricity needs. Some, it's just another input cost, right? And so while it may be important to them and they want to show a sustainability agenda, it's not like they're trying to show grid policy leadership
Yeah.
unless it's through an aggregator. Now, a lot of them are using aggregators increasingly to help with that. There's certainly companies like, Microsoft, Google. I won't name all the names, but they're obvious because of their data center usage. So they often have loads that are in the hundreds of megawatts because these are very power intensive applications. So, and they want to be on the cusp of sustainability as well. So they tend to be doing lots of different things. It does beg your point, we're not often, we can try co-locating with them, but we're going to still have to provide grid services. In a lot of cases, there's going to have to be a virtual power purchase agreement. Yeah. That stuff is continuing to mature as well. In our case, the mining sector also tends to be one that comes forward and is definitely trying to come up with more sustainable mining methods. A lot of them have significant grid loads. What's interesting for us is that often there's a natural synergy with their subsurface infrastructure and what we do. So that, for example, like our Silver City project in Australia is at a mine in that type of application. And in a sense, it's providing them with a backup solution as well as the whole town to make sure it doesn't go down when a long radial line isn't available on the system. So, there are definitely cases where those types of entities are coming forward. But I would also point out that, like we're all part of a community that's looking at energy transition and is really trying to push adaptation and even institutional adaptation. But sometimes I hear in conversations that are less well informed that, that's where everything's going to go. It's all just going to go down that pathway. And I think it will become an important part of it. But I go back to the grid planners, the regulators. This stuff is not going away. And and in part, the energy transition industry is providing solutions, needs to be able to adapt to that too. And not just try to say, oh, the institutional framework needs to adapt to us. To be fair, there needs to be both of that. But that's why we spend a lot of time making sure we're able to be truly the transition part, moving. If a coal plant's retiring, then it needs a replacement there. It doesn't need that entire grid to be then suddenly shifted to decentralization. That can maybe happen over the decades subsequent to that through natural policy evolution or as technology evolves.
Yeah, I concur. The centralized grid will certainly still play a factor. I personally think there will be distributed energy resources will be needed or required, probably because it can be done faster than some of the regulators, right? But
that's true. I don't mean to say they're not we're sort of part of that community. I just think we're kind of a transitional piece between just given a slightly larger scale. The intent is to take distributed energy resources and variable intermittent resources and make them non-intermittent in the first place and able to provide that reliability piece on the grid where it's required. So it's a bit of a hybrid for sure.
It is. And I see it as a pending solution that, large aggregate of companies could perhaps be utilizing in some fashion. I recognize it's not that simple, but it's just something that maybe could be used as well.
Yeah, for sure.
Okay, next question then. I think we all agree, and I think most people understand, that there's going to need to be some kind of storage element at a grid scale for the transition. So if we take that as a base, we also take as our next base that many of our listeners, when you talk to them about energy storage, will immediately be thinking batteries. So my question really is, at the grid scale level that you're operating at, what is the difference between battery storage and the HydroStor principle?
Yeah, really good question. We obviously get this question a lot. But what's interesting, though, I'll preface the response by saying, like, we actually look at deploying batteries. I mean, batteries are really doing different things, and we can integrate batteries into our system to provide a full range of services in the most cost-effective way imaginable. And we look at deploying those kinds of solutions onto the grid. So they are different. They're very different. And we're not saying batteries are going away. I think where we get a little skeptical about the battery industry is when they just try pushing their use case to every imaginable possible application, including long duration storage. And I would say, if you just look at a high level at their differences, which I don't think would be that surprising to your knowledgeable listeners, is, look, these things are modular. You can put them relatively quickly on the grid. You're going to be subject to supply chain constraints, right? This is a manufactured product, and an increasingly centralized manufactured product that is subject to trade flows, and you are offshoring a lot of your grid infrastructure in that case. So these are considerations. It's not unique to batteries, but that's a big difference between batteries and compressed air. Like, we're an infrastructure asset that gets built in a steel in the ground and is really long term. And that's another big piece. I mean, batteries are not a long-term device. So you're putting them in, you're going to continue replacing them. There's performance degradation that's actually still uncertain for the utility scale applications. Like, let's not forget, people have been talking about batteries for a long time. Most of these projects, I mean, I don't think there's any project that's really been operational more than 2 years at like a grid scale. I mean, my phone works okay in the first year that I'm using it, right? I say this in jest, but it's the exact same cell, right? There's no difference. It's exactly the same technology, like zero difference. So, it's kind of common sense. Like, what's going to happen in 7 years down the road, or is there additional augmentation required? I'm sure a lot of battery interested listeners will, come on with a whole bunch of comments as to how that's being addressed and so on and so forth. And I don't doubt that it is being addressed on some level, but this is a fundamental difference between a mechanical technology and a chemical one. There's always going to be some element of performance degradation. We debate how much, and there really isn't on this compressed air asset. And I think one of the things that gets lost in all of this, like, we talk about cost and we compete on cost, and we talk about the need to replace replace fossil plants. But let's just take a step back and say, well, if you need long duration storage, let's do an environmental life cycle assessment of that resource to provide that solution. We're actually looking at commissioning studies like this now because we're starting to get aggravated. There's a lot of studies out there. I don't want to, I guess I have to say it's a public study anyways, but NREL just came out with a study that frankly is really frustrating because it's fantastic work quality, but they look at, pumped hydro, different technologies and the life cycle implications of doing them. And their conclusion is mostly around, closed loop pumped hydro, like the thing they know. And they look at compressed air, but it goes back to the point that they're looking at traditional compressed air. So what about advanced compressed air, right? Like, if you actually look at our life cycle impacts, they're extremely low, much lower than pumped hydro, because we're having much less impact on the landscape environment, methane emissions. If you look at the life cycle of pumped hydro, it's actually, I'm not saying you shouldn't build pumped hydro resources. Don't get me wrong. I'm just saying that needs to be factored into thinking. And obviously battery disposal needs to be factored in, the mining of the materials required to do that. And, for us, obviously, that steel needs to be considered. But if you look at that, I mean, there's a substantial difference. And I think people are going to start caring more about those life cycle impacts as well. That's not being talked enough about. So, if I take a step back and say today, what would I use batteries for? They're very fast responding. They can provide short duration solutions pretty cost effectively. Go nuts. I mean, every application that's out there is for that right now, and maybe hitting even frequency response markets. But for long duration storage, that's a whole other question. So I think to me that's a fundamental difference.
John, can I have a follow-up on that? Because I don't think we've asked you this. When you're employing this technology, what length of time, duration does it from the start of the project to actually get it up and running? How long does it take? Because building these generation plants typically can be quite like time consuming if we're talking about nuclear or other. So can you share?
Yeah. I mean, it depends on the scale of the facility for us, but at that typical large scale where we're building out a greenfield plant, it's about 4 to 5 years of construction total. And then it's really grid or jurisdiction dependent how much upfront development time is required, but call it 2 years, right? So it might be 6 to 7 year lead time from the time period that it's like a nugget in someone's brain. The challenge, though, that we've had, and we've had a lot of success because we think we're providing, a valuable benefit, but in jurisdictions that aren't there yet, we have to spend a lot of time working with them explaining the lead time requirements because otherwise they sort of look at the grid and say, well, where are we now, 2023? Usually they're looking ahead about 4 years and they're like, oh, 2027, we have a big problem here. And then they're running like panic RFPs that you can't supply a solution for. And that's not in anybody's interest. It's not in their interest. They're supposed to be doing least cost planning. So where we've been successful is because the regulator and grid planner have got that. California put in place mandates around a defined regulatory term, long lead time resources. And because they recognize if they're going to minimize costs and make sure they have decarbonization solutions, they need to plan ahead for that while also dealing with their urgent needs. It's similar to what they're doing in Australia as well. But I'll tell you right now, there's a lot of other jurisdictions that need to catch up on that. And, we'd love to deploy something quicker, but it comes with other benefits. I mean, it does take time to build hard infrastructure in the ground anywhere. But that is a 50-year plus resource that's there forever, provides all the local economic development benefits, jobs, has significant operational jobs because it's not a plug and play device and isn't offshored. So you really want the diversity of all of these things. But then there needs to be some adaptation on how you're procuring and getting these types of resources on the grid.
Right. Well, it really reinforces how we have to educate the regulators so they can speed up and get moving on this whole piece, for sure.
Absolutely. And it's not like, even what they're finding in California, we've been talking to them mostly about their long lead time resource timelines, but already they're putting in extensions in place for the like midterm reliability needs because the supply chain impacts for sure, it's quick to pop in a battery, but what happens when there's inflationary environment, the manufacturer shuts down in China, not your jurisdiction, you don't control. Like that's why people talk about diversity. They usually talk about diversity in a way that's kind of like, well, motherhood and apple pie, do the most efficient thing for them, like Texas, and build just gas and wind. And then when what was probably foreseeable occurs, they go back to talking about diversity.
Right.
So it's more than a motherhood and apple pie term. It requires some significant planning and foresight and intent to do it up front.
Right.
Thanks for another great episode, John. To end off this episode, what is the biggest takeaway for our listeners?
I think from our perspective, I would look forward to advanced case. I mean, maybe case generally, but especially advanced case as a true storage asset, really emerging as the third immediately available long duration storage pathway. We already are that effectively in California and Australia, and it's generally recognized there. That's not always understood, I don't think, in other jurisdictions. And when I say third, what do I mean? Well, you can do batteries. We just talked about batteries. You can lump them together into an 8-hour plus application. It will be very expensive. And you have all these drawbacks that we had talked about before. You can do pumped hydro. I think that's well understood. But the challenge with that is where can you do the pumped hydro and get it permitted? I mean, one of the reasons we've been successful in Australia and California is although there's a lot of pumped hydro projects proposed, like these aren't places that aren't looking at pumped hydro. They're either proving to be not permittable, not developable in the same time frame, or having massive cost overruns because they require 10 times the amount of civil infrastructure. So again, that should be pursued where it's developable. But today, this can be developed with performance guarantees, project financing, bank backstops. We have the backing of Goldman Sachs. And so this is here today. And for us, it's an important message too, because we're really trying to work with the whole industry, pumped hydro, battery providers, ourselves on compressed air, but also all these emerging technologies, some of which are very promising, and flow batteries and other approaches to long duration storage, to make sure the market's moving in the right direction and that we all compete. But when we have that conversation as HydroStor, we often get lumped in the category of sort of emerging energy technologies if we're not really well understood. And we're really not that. And in jurisdictions like in California and Australia, they recognize that. We're there today to do that. And we're there today to immediately do the energy transition while we're growing a whole bunch of other different approaches that are really trying to develop their pilot scale applications to prove out their performance or manufacturing capabilities. And as we were talking about before, with the urgency required on the grid, we can't wait forever on that. So we really need to focus on this three pathways of resources right now, while not holding up long duration mandates.
Thanks for that. Dave, what was your biggest takeaway?
I think it continually gets reinforced when we talk to people like John, the importance of regulators being well-versed and speeding up their decision-making. The idea that the public needs to be understand and help support and get this advancement. And I think the last thing, like we've talked with John, the idea that this is actually supporting the current infrastructure. There's going to be jurisdictions that are going to be doubling or tripling their electrification requirements. That just means there's going to be another even more or a larger market for John's solution going forward. So I think I'm hopeful this podcast will educate the people in the marketplace and help get this type of technology in the marketplace faster.
Yeah. And, to reiterate for us, although that's our view of our positioning, it's really about long duration storage. I mean, the big thing that the influencer stakeholders that we were talking about before need to do is define that attribute that's required and let the industry respond with the most cost-effective solutions. And like I said before, and I mean it, quite seriously, I wish the best of success to all these types of technologies, because we're going to need all of them. But we do need to send the market signals now. And this isn't, technically we should have sent them probably 5-10 years ago, but we are where we are. But we shouldn't be looking at another 5-10 years and still navel gazing as to what's required.
John, what's your biggest takeaway?
There's always the trouble of coming last in the biggest takeaways, that lots of things have been taken by the time they've got to you. But I think something that really resonated with me was something that John said, and it was about, we could be pursuing more efficient air compressors, but that would put us in the laboratory. But what we're doing about is delivering now. And it's along the lines of, we've got something that's acceptable. Let's get it in the marketplace now and doing the job, rather than working for perfection that we might never achieve and might miss the market. So I think there's a really important message there.
Yeah, we need to do both, and one shouldn't be an excuse for the other.
No.
So,
for me, my biggest takeaway, we talk about this all the time, especially internally amongst Dave, John, and I, life cycles. And I think it's important to understand not only the immediate benefit in the application of a technology, but the longevity and what comes with its end of life especially. And John, I think you communicated that very well. So thanks for that.
Yeah, thank you. And again, I really appreciate the opportunity to talk to you guys again.
It's been really interesting.
Thank you,
John.
Thanks. Have a great week.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360 Energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn posts. See you next week.